Mercury is a planet of extremes. It is the smallest planet in our solar system and also the closest to the Sun. This makes it a fascinating object for astronomers. We are still learning about its secrets. Mercury is named after the Roman messenger god, which is fitting because Mercury moves quickly. It has the fastest orbit of any planet, zipping around the Sun every 88 Earth days. Despite its proximity to the Sun, Mercury is not the hottest planet. Venus holds that title. This is because Mercury has almost no atmosphere to trap heat. Temperatures on Mercury can fluctuate wildly, ranging from scorching hot to freezing cold. Mercury is a rocky planet covered in craters, suggesting a history of asteroid impacts. These characteristics make Mercury a unique and intriguing world. It is a place of both intense heat and frigid cold. It is both familiar and alien. Mercury's orbit is highly elliptical, meaning it is not perfectly circular. Mercury is much closer to the Sun at some points in its orbit than others. This has a dramatic effect on the planet's temperature. At its closest point, Mercury is about 29 million miles from the Sun. At its farthest point, it is about 43 million miles away. This difference in distance causes extreme temperature variations. On the side of Mercury facing the Sun, temperatures can soar to 800 degrees Fahrenheit or 430 degrees Celsius. On the side facing away from the Sun, temperatures can plummet to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. That is a temperature swing of over 1,000 degrees Fahrenheit. Mercury's lack of a substantial atmosphere contributes to these extreme temperatures. Without an atmosphere to trap heat, the surface of Mercury heats up quickly when exposed to sunlight and cools down rapidly when in shadow. Mercury has a very thin atmosphere. It is almost non-existent. This is because Mercury is so small and its gravity is so weak. The Sun's heat has stripped away most of its atmosphere over time. The few gases that do exist around Mercury form a thin layer called an exosphere. This exosphere is made up of particles blasted from the surface by solar wind and micrometeoroid impacts. It is constantly being lost to space and replenished from below. Beneath Mercury's exosphere lies its solid rocky surface. This surface is heavily cratered, much like our moon. The craters were formed by impacts from asteroids, comets, and other space debris over billions of years. The lack of an atmosphere means that there is no weather on Mercury. There is no wind, rain, or erosion to speak of. This means that the craters on Mercury's surface are incredibly well preserved. They offer a glimpse into the early solar system. Mercury has a very slow rotation period. It takes about 59 Earth days for Mercury to rotate once on its axis. This is unusual because Mercury orbits the Sun quickly. The combination of Mercury's slow rotation and fast orbit creates a strange phenomenon. On Mercury, a day is longer than a year. A single day-night cycle on Mercury takes 176 Earth days. That's twice as long as it takes Mercury to orbit the Sun. This means that if you were standing on the surface of Mercury, you would experience extreme temperature differences over the course of a single day. You would bake in the intense heat for 88 Earth days, then freeze in the bitter cold for another 88 Earth days. Scientists believe that Mercury's slow rotation is due to the gravitational influence of the Sun. The Sun's gravity has acted like a brake, slowing down Mercury's rotation over billions of years. Mercury's surface is a testament to its violent past, covered in craters of all shapes and sizes. Some are small and bowl-shaped. These craters are scars from collisions with celestial objects. One of Mercury's most prominent features is the Caloris Basin. This colossal impact crater spans 960 miles. It is one of the largest impact basins in the solar system. Despite its small size, Mercury is surprisingly dense. In fact, it is the second densest planet in our solar system, after Earth. This high density is a clue to Mercury's internal structure. Scientists believe that Mercury has a large iron-rich core. This core makes up a significant portion of the planet's interior. It is thought to be responsible for generating Mercury's magnetic field. The presence of such a large core is unusual for a planet of Mercury's size. One theory is that Mercury was once much larger. However, it lost much of its outer layers in a giant impact early in its history. This impact could have stripped away some of Mercury's lighter elements, leaving behind a planet that was proportionally richer in heavy elements like iron. This would explain Mercury's high density. Understanding Mercury's internal structure is crucial for unraveling the mysteries of its formation and evolution. It can also provide insights into the formation of other rocky planets in our solar system. The enigma of Mercury's magnetic field. Despite its slow rotation, Mercury has a global magnetic field. This is unusual because a planet's rotation is typically thought to be essential for generating a magnetic field. While Mercury's magnetic field is much weaker than Earth's, it is still a significant feature. This magnetic field provides some protection from the solar wind, a stream of charged particles constantly flowing from the sun. The exact mechanism behind Mercury's magnetic field is still not fully understood. Scientists believe that it is likely generated by the movement of molten iron in the planet's large outer core. However, Mercury's slow rotation should have caused its core to cool and solidify over time, shutting down its magnetic dynamo. The fact that Mercury still has a magnetic field suggests that something is keeping its core at least partially molten. One possibility is that tidal forces from the sun are constantly kneading Mercury's core, generating heat and keeping the iron molten. Further study is needed to fully understand this enigmatic feature. The challenges of exploring Mercury. Exploring Mercury is no easy feat. The planet's proximity to the sun presents numerous challenges for spacecraft and instruments. These challenges include 1. Intense heat. Temperatures on Mercury's surface can reach a scorching 800 degrees Fahrenheit. Designing spacecraft and instruments that can withstand such extreme heat is a major engineering challenge. 2. Solar radiation. Being so close to the sun, Mercury is bombarded by intense solar radiation. This radiation can damage sensitive electronics and instruments. Spacecraft must be shielded to protect them from this harmful radiation. 3. Gravity. Well, the sun's strong gravity creates a deep gravity well around Mercury. Spacecraft must use a lot of fuel to enter and escape orbit around Mercury. This limits the amount of scientific equipment that can be carried. Despite these challenges, several missions have successfully explored Mercury. These missions have provided valuable data and insights into this enigmatic world. Unraveling Mercury's secrets from afar. Despite the challenges, we have sent robotic explorers to unravel Mercury's mysteries. These missions have provided invaluable insights into this extreme world. NASA's Mariner 10, launched in 1973, was the first spacecraft to visit Mercury. It flew past the planet 3 times, capturing the first close-up images of its cratered surface. In 2011, NASA's Messenger spacecraft became the first to orbit Mercury. Messenger spent 4 years studying the planet's composition, geology, and magnetic field in unprecedented detail. It revealed surprising features like water ice hidden in permanently shadowed craters at Mercury's poles. These missions have transformed our understanding of Mercury. However, many questions remain unanswered. Future missions will continue to explore this fascinating world. Studying Mercury is important for several reasons. It offers a unique window into the processes that shaped our solar system. As the smallest and innermost planet, Mercury provides clues about the conditions in the early solar system. Its unusual composition and internal structure can help us understand how planets form and evolve under different conditions. By studying the effects of the sun's gravity and radiation on Mercury, we can gain insights into how these forces affect other planets. This knowledge is crucial for understanding the habitability of planets beyond our solar system. Mercury's extreme environment also serves as a testing ground for new technologies and exploration strategies. These technologies and strategies can be applied to future missions to other challenging destinations. The exploration of Mercury is far from over. New missions are already being planned. The European Space Agency's Bepi-Colombo mission, launched in 2018, is on its way to Mercury. It is expected to arrive in 2025. Bepi-Colombo will study Mercury's interior, surface, and magnetic field. Future missions may include landers or rovers. We are sure to make new and exciting discoveries. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment.